So hi everyone. Next we are going to start with third unit equation of motion under the second chapter motion in one dimension for class 9 physics and Thomas School Ranchi. So under this third unit we are going to see all the equations of motions and how it is being derived with the help of graphical method. So as we know, these the three formulas of motion: v is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2as. So here v represents final velocity, u represent initial velocity, a represent acceleration, t represent time, s represent total distance covered. So these are all some of the symbols which we have used, and I think you all are well known about these all symbols and these three equations of motion: first equation, second equation, and third equations of motion. So now with the help of graphical method we are going to solve all these three equations. So here we are going to consider one condition that's observed. Suppose an object is in linear motion with its initial velocity u, and after some time it attained some velocity and gets the final velocity as v. Based on this we are going to plot a graph. So when we have plotted a graph of velocity time graph, taking velocity in y-axis, time in x-axis, what you're observing that so body has now started from rest. After some time it attained the velocity u, and at last it reached the velocity of v, and this is the uniform velocity what we have got. So in this graph what we're observing that it has two portions. This is one triangle we have got, and second one rectangle we have got. Now with these two portions of graph we are going to derive these all three equations. So first equation we are going to derive, the first equation is v is equal to u plus at. If we will resolve this equation, what we are going to find out that we have to find out the acceleration a is equal to v minus u by t. So this formula we are going to derive with the help of this graph. So now to deriving this acceleration with the help of this graph, what we are going to do, we are going to find out the slope of this triangle AEB, and when we will find out the slope of this triangle we can able to find out the acceleration. So how we will find out the slope, as we have discussed in second unit, to find out the slope of this triangle, delta y by delta x. Thus BE, which is delta y portion, and AE, which is delta x portion. And when we will resolve this we will get v minus u by t, and thus we get the first equation of motion. A is equal to v minus a, simple formula of acceleration, and this is the first equation of motion. V is equal to u plus at. This is the first equation of motion. Now next come to second equation of motion. So now to find out the second equation motion, again we have the same graph, and what you're observing that this is the first triangle and another one is rectangular portion. And what we are going to find out, that second equation is all about finding the distance, total distance covered. And to find out the total distance covered with the help of velocity time graph, we have already learned in second unit that we have to find out the areas of these two portions. This is one triangle, this is one rectangle. So that is what we have found out, the area of triangle plus area of rectangle. So area of triangle is being found with the help of half base into height. Area of rectangle is found out with length and length into breadth. So here it is, S is equal to half A into B. A is the base and B is the height, and area of rectangle OA into OD. So S is equal to, substituting the value of AE and BE, S is equal to half t into v minus u, and here OA and OD gives us u into t. And now here the important thing is that in a place of v minus u, we are going to use the first equation of motion, v is equal to u plus at, and thus v minus u is equal to at. This value we are going to substitute here in v minus u, and after substituting, what it is going to happen to this equation? So this equation comes as s is equal to half t into at plus ut, and thus when we will resolve this equation, we will get the second equation of motion, s is equal to ut plus half at square. Now come to the third equation of motion. So to find out the third equation of motion, what we are going to do, again we are going to find out the total distance covered by an object. So when we are going to find out the total distance covered by an object, what we are observing in this graph? In this graph we see this is a kind of one trapezium. We are going to find out the area of this trapezium to find out the total distance covered by an object, and then to find out the area of this trapezium, we get the formula half sum of parallel side into this height of trapezium OD. So when we have added, s is equal to half u plus v into t, we got. And now here again what we are going to do, instead of this t, in a place of t, we are going to use the again first equation of motion, t is equal to v minus u by a. This value of t we are going to substitute in a place of t here, and then we will get half u plus v and v minus u by a, and thus at last we will get the s is equal to half 2a under bracket v square minus u square, and then we will finally we got the third equation of motion, which is v square minus u square is equal to 2as. Thank you.